So today we're graphing the absolute value function. All right, so remember the absolute value of a number is its distance from zero on a number line. All right, so you might remember that we use these bars to represent absolute value. So if I said the absolute value of 7, we're talking about how far away is 7 from 0 on the number line? Oh, well, it's 7 steps away. What about the absolute value of -4? How far is the -4 away from 0 on a number line? Well, it's 4 steps away. And the easiest way most people remember absolute value is just to say, oh, whatever number it is, just make sure it's positive and that's the answer. Like if it's 7, well, it's already positive, so it stays 7. If it's -4, oh, we make it positive, and then that's the answer, so it's +4. All right, but how do you graph the absolute value function? So here's an example of the absolute value function. F of x is equal to a times the absolute value of x minus h plus k, where x is our variable. Okay, so this is the generic formula for the absolute value function. Now, there's some things you need to know in here, though. Okay, so x minus h, that h represents how much we're shifting the graph to the right. Okay, so however much we're subtracting, that's how much we're moving to the right. Now, if this is positive, though, then that means we end up shifting it to the left. Okay, similarly, see the plus k? The amount we're adding at the end of the absolute value symbol is how much we're shifting up. Okay, so if it's +5, we're going to move it up 5. But if it's subtracting, then we're going to go down. So this is a little tricky for a lot of people because we're subtracting on the inside to move right, but we're adding on the outside to move up. All right, and then the last thing, this a in front of the absolute value. We're multiplying the absolute value by a. That's the vertical stretch. So that's how much we're stretching this thing or dilating it vertically. Okay, so whatever number that is, we're stretching it to be that much taller. Now, if there's no number in front of it, it just means there's a 1. So it just doesn't stretch at all. And I'll give you some examples of that too. All right, but down below, I have some examples, and on the graph already is the parent function. In other words, the most basic absolute value function, which is simply f of x is equal to the absolute value of x. So if we didn't stretch it, we didn't shift it at all, this is what the graph would look like. And it makes sense if you think about it, right? Because if x is 0, the absolute value of 0 is going to be 0. If x is 4, the absolute value of 4 is going to be 4. If x is -4, the absolute value of -4 is going to be +4. So it ends up making this V shape, and it never goes into the negatives because if you take the absolute value of a number, it's never going to be negative, right? Unless we end up doing something to it, which is what you're going to see. Okay, so let's try this out. Okay, we've got the graph of f of x equals the absolute value of x already on there, and I want to graph the f of x is equal to the absolute value of x minus 3 minus 1. Okay, so let's think about what this says. We've got this -3 here. That means we're shifting it 3 to the right. We have also got a -1 on the outside of the absolute value, so that means we're going to shift it down. Okay, so I always like to start with the vertex of this V, that point right there. So we are shifting that 3 to the right and 1 down. So that vertex goes from here to here. It just went 3 right, 1 down. And there's no vertical stretch. So that means this whole V just stays the same, except it just moves over 3 and down 1. So now my V ends up going diagonally like this. Here, I'll put arrows. And it'll go diagonally the other way as well. There you go. And you'll notice that the angle of this line, it just goes diagonally through all these squares like that. And that's what we end up having here too. Okay, so that whole V just ends up shifting over 3, down 1. Here, let's do another one. This time we've got f of x is equal to the absolute value of x plus 2, and then outside of the absolute value, plus 4. Okay? So what this tells me is this plus 2, this time we're not subtracting, we're adding. So this time we're shifting it to the left 2 and up 4. All right, so this vertex is going to go left 2 and up 4. 1, 2, 3, 4. There's my new vertex of this V. And notice again, there's no vertical stretch. So that means the angle of these lines is just going to stay at that diagonal. All right. You could think of it as each side is a slope of 1, right? Because it's up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And I just keep that the same. Okay? All right. Now, let's do some slightly harder ones and mix in some vertical stretches. Okay, so let's do it. Here we go. Again, I left the parent function on there so that way we can kind of compare our work, our new equation work with the original. Okay, so notice f of x is equal to 2 times the absolute value of x minus 5 plus 2. So there's 3 things here. There's a horizontal shift, there's a vertical shift, and there's a stretch. So let's do the shifting first. The original vertex is here. We need to shift this 5 to the right and 2 up. So from here, 1, 2, 3, 4, 5, and 2 up. 1, 2. Okay, now the original graph goes up 1, right 1, up 1, right 1, up 1, right 1, right? We're going to stretch it vertically times 2. Not horizontally, just vertically. So instead of up 1, right 1, we're going to go up 2, right 1. Up 2, right 1. And notice, I've doubled, because the vertical stretch is 2, I've doubled the vertical rise, but I haven't changed the horizontal. So instead of up 1, right 1, I'm up 2, right 1. 2, right 1. 2, right 1. So this side of the V ends up looking like this now. See how it's steeper? And then we'll do the same to the other side. Instead of up 1, back 1, up 1, back 1, I'm going to be up 2, back 1. Up 2, back 1. Up 2, back 1. So it ends up looking like this. It's like a skinnier V. Or you could think of it as stretched out, vertically stretched V. And it's been shifted over 5 and up 2. All right. All right, last one. This is going to be the hardest one. F of x is equal to negative 2 times the absolute value of x plus 4 minus 1. So again, we're doing all 3. We've got a horizontal shift, a vertical shift, and a vertical stretch. So let's do that. The horizontal shift is plus 4, so that means I have to go to the left 4. And my vertical shift is down 1. So my vertex went from here to here. All right, now my vertical stretch is negative 2. So remember, a positive 2 took the angle of this line. Instead of going up 1, right 1, we went up 2, right 1. This time, instead of going up 1, right 1, it's negative 2. So that means instead of up 1, right 1, I'm down 2, right 1. Down 2, right 1. So I've multiplied this vertical, I guess you could say the rise of this slope. Instead of the rise is positive 1, the rise becomes negative 2. And again, the run doesn't change because it's a vertical stretch, not a horizontal stretch, just a vertical stretch. All right, so that's this side of my V. On the other side, it was up 1, back 1, up 1, back 1. Now instead of up 1, it's down 2, but it's still back 1. Down 2, back 1, down 2, back 1, down 2, back 1. There's the other side of the V right there. So it takes this V, stretches it vertically, and flips it upside down because of the negative, and it ends up down here. All right? So a little tricky, takes some getting used to. The key here is using what we know about the general form of an absolute value function to shift the vertex, and then we can use that vertical stretch to figure out how steep the sides of the V are going to be. Okay? So hopefully you found this video helpful. If you did, please hit that like button. Also subscribe because it really helps us out. But with that being said, good luck on your math, and I will see you next time.